The following problem asks us to calculate the pH of a ammonia solution, and it gives us the molarity, and it gives us a Kb. The first thing that jumps out to me is the minute that it says a Kb or a Ka, it tells me something. In this case, I know that it is a weak base. So a weak base will produce hydroxide, and I need to figure out how much of that hydroxide is produced. It is not going to be 0.00125 molarity. So first we need a chemical equation. So all bases will react with water, and if I write water as HOH, that will make it easier for me to understand that. So a base accepts hydrogens. So that means that my water in this case is going to be acting as my acid, and it's going to be giving an H to the ammonia. And that will create ammonium ion and a hydroxide ion. All right, so let's lay it out in an icebox format. Water is a liquid, so that is not going to count. And I was given the initial concentration. So that's all I have. So in the beginning, these are zeros. So because those are zeros, my reaction is driving itself to the right. So I'm gaining while this is losing. And that is my icebox. So I do know a couple things. One, if I was asked for the expression, the equilibrium expression, it would look something like this. And these problems are not as difficult because it is a 1-to-1-to-1 ratio. But if it weren't, we would need exponents. So what I'm going to do is I'm going to be plugging these numbers in. So this is my expression equaling my Kb. Here is one major issue, is that this is not 100 times greater. I'm a little worried of what this value is going to be. So if I do solve for x right now, I get 1.5 times 10 to the negative fourth. Okay? If I take that over the original amount, I roughly get 12%, 0.12. And what we start to learn is that there's a 5% validity rule where if I'm going to cross this x off, my final difference between my x and my original amount has to be 5% or less. Then that is valid. It is not. So what does that mean? I need the quadratic equation. All right, this is bad. So I need to start over, and I need to not have my x being crossed off. So I'm going to isolate this right here, and I'm going to extrapolate that out. If you want to work on that, I'd suggest pausing that. Otherwise, I'm going to show the relationships of trying to get it into my ax squared plus bx plus c equals 0 format. That's my goal. So if I extrapolate that out, this is what I calculated. So now I need to plug that in the quadratic. So if I plug that into this equation, the quadratic equation, I get two answers. You always get two answers, and usually one makes sense and the other one does not. So here are my two answers that I get. One is 1.413 times 10 to the negative fourth. And the other is negative 0.001593. So this one clearly cannot be the right answer because I can't have a negative amount that is created. So now that is going to be my X, which ultimately equals my concentration of OH. So how do I get to pH? Well, I need to utilize a few equations. So the first one is going to be negative log of OH minus. So if I take the negative log of my OH concentration, I get 3.85, roughly. I finish that off by taking 14 and I subtract 3.85, and I get 10.15 for my pH. And that should make a lot more sense because this is a base. The pH should be greater than 7. So if you get 3.85 and feel like you've ended, maybe you are in POH, and that would tell you right now, if you thought it was pH, that that was acidic, when in essence, it is actually still saying it's basic. So that is how you calculate a pH of a weak acid solution when needing to use the quadratic equation.